Now, factors affecting attenuation. So, there are two major players that control how much sound gets lost as it travels. Main factors here are the medium, what's inside, and second is the frequency. So, medium, what sound travels through? Tasween, what are the examples of different medium?
There's air, there's fluid, there's tissue, there's water, there's bones.
Yes, fluid, bone, air, soft tissues, different medium. So, which one among them has low attenuation?
Low attenuation, that would definitely be fluid.
Yes. So, fluid has very low attenuation. For example, urine, bile, cysts also contain the fluid. So, sound pass easily, and we can see posterior enhancement behind them, brighter areas behind the fluid. And which one among them will be high attenuator?
Bone,
Bone. Okay, good. What about air?
air.
Yes, air.
Okay, there's also high attenuation.
Yes. Very high attenuation occurs in air. From air, almost like 99.9% of the sound is reflected back. And also from the bone, there is a very high amount of reflection, so that we can see a shadow behind the bone, and also behind the ear we can see dirty shadowing as well. And when we see a stone, we can see a shadow behind it. Why? Because stone is also dense, so there is high attenuation from the stone. So that's why we can see a shadow behind the stone and the bone and the air. What about soft tissue?
There is attenuation in soft tissue.
Moderate?
It is more than fluid, lah.
Yes, more than fluids and less than bone and air. So moderate attenuation, so normal brightness is seen in the soft tissues. Okay, now frequency. So frequency controls how fast the sound wave vibrates. We know it's number of cycles per second. So that directly affects how much energy that gets lost. Higher frequency, more penetration. More attenuation. Higher frequency, more attenuation. And if there is more attenuation, what about penetration?
Less.
Yes, less penetration. And low frequency mean less attenuation but more penetration. Yes. So these two are the main factors. One other factor is the distance. So we know as the path length increases, attenuation also increases. So when it reaches to the deeper tissues, it gets weaker. That's why deep structures appear dim as compared to the superficial structures on ultrasound. So medium, frequency, and distance. If there is fluid, there is low attenuation. If there is bone and air, high attenuation. If there is increased frequency, increased attenuation. And if there is increased distance, also attenuation increases. Okay, Teswin, can you please now repeat about the medium effect?
Okay, so medium, which is what sound travels to. For fluid, it has low attenuation, sound passes through easily. That's why we have posterior enhancement. Soft tissue has moderate attenuation. Bone air has the highest attenuation. It is a strong reflector and it absorber as well.
Yes, there is strong reflection and absorption and very less transmission from the bone and air because of the high attenuation. So we can see shadow behind them. So fluid, we can see sound transmits easily. It does not block the sound. Bone, sound gets blocked. Air, sound gets blocked. And there is more reflection back. And there is less transmission from the air. And from the tissues, there is a moderate level of transmission, like some reflection and some transmission. So soft tissues have a moderate attenuation, fluid very low. That's why we can see posterior enhancement behind them. Bone air have very high attenuation, so we can see shadow behind them. Now this means what are the examples?
Okay, we have gallstones, which give us clean acoustic shadowing, and we have cysts, which gives us a very visualized posterior enhancement.
Okay, good. So what we can see here in this image?
Those gallbladder stones.
Yes, gallbladder stones, and we can see posterior acoustic shadowing behind them. Okay, now what we can see here in this image?
There is posterior enhancement below of the cyst.
Good. There is posterior acoustic enhancement below the cyst. Okay, now relationship with the frequency. So higher frequency means more attenuation but less penetration. So high frequency is used for the superficial structures only, where there is less penetration required. Lower frequency, less attenuation, so that's why it's preferred for the deeper penetration. So how to remember this? High frequency, high fade. So when there is a high frequency, there is more weakening, there is more attenuation of the sound being. Now its relationship with the frequency. So when frequency increases, attenuation coefficient also increases. For example, if attenuation coefficient was 0.5 at 1 megahertz, when we increase the frequency, we make the frequency 3 megahertz. So then this attenuation coefficient also increases. 0.5 multiply 3, it becomes 1.5. When frequency becomes 5 megahertz, this attenuation coefficient again increases. 0.5 multiply 5, it becomes 2.5 decibel. So we can see here, as the frequency increases, so the attenuation coefficient also increases along with it, and so as the attenuation. So lower frequency, less attenuation, higher frequency, more attenuation. This is important point to remember, that attenuation is directly related with the frequency. Increased frequency means there is more attenuation. Okay, now attenuation coefficient. So that's equal to 0.5 decibel per centimeter per megahertz in soft tissues. Like for 1 megahertz is it's 0.5 decibel per centimeter. Okay, Tasween, how can we define the attenuation coefficient?
This is by the distance traveled.
Okay, it's amount of attenuation per centimeter of the travel. So its unit is decibel per centimeter. Amount of attenuation per centimeter. We know when distance increases, the centimeter value increases, attenuation also increases. So attenuation coefficient is amount of attenuation per centimeter of travel. Unit is decibel per centimeter. And in which medium attenuation coefficient will be highest?
Definitely it would be on bone.
Yes, bones, because there is strong attenuation in the bones. What about the fluid?
Fluid is the lowest.
Low attenuation in the fluids, so low attenuation coefficient. And each tissue has its own attenuation coefficient value. In soft tissue, it's 0.5 decibel per centimeter per megahertz. So attenuation coefficient is the rate of attenuation per centimeter per unit path length. So its unit is decibel per centimeter. And how we can calculate the attenuation? Attenuation formula is alpha. What is the alpha? It's the attenuation coefficient multiply distance or path length in centimeter multiply frequency in megahertz. So that's the formula for the attenuation. Okay, so Teswin, for the soft tissues, if the frequency is 1 megahertz and the distance is 2 centimeter, what is the value for the attenuation?
So it's 0.5 times with 2.
What's the answer?
It's 1.
Yes, it's 1. So that's the formula to calculate the attenuation, and this is important formula to remember. So now, Tesween, what do you think? What is the clinical implications of all these relationship with the frequency and attenuation?
Alright, so basically we should remember higher frequency is higher attenuation, less penetration. So we should use low frequency for deeper organs, higher frequency for more superficial structures. Alright, and to identify tissue composition, we should recognize the shadowing or enhancement, posterior enhancements. So, for example, how you can be aware of gallbladder stone shadow and liver cyst enhancement.
Okay, good. And how we can optimize attenuation effects?
We can adjust TGC and overall gain, use compound imaging to reduce the scattering, and balance frequency and penetration depending on the scan.
Yes, if we scan deeper structures, we will prefer less frequency. If we scan superficial structures, we will choose higher frequency, and we can use compound imaging because it reduces the scattering noise. There is a knob of the compound imaging, so we can use that to reduce the noise from the image, and we can adjust overall gain and the TGC, time gain compensation. This means what is the difference between overall gain and time gain compensation?
Gain composition is actually it follows the depth of the structures. Overall gain is the brightness of the overall 2D scan.
Okay, good. So in overall gain, we adjust the brightness of the whole image. Like we change the brightness in our mobile phone screen. So we can either increase the brightness or decrease the brightness. Now we know that there is attenuation. So the structures which are in the far field, they appear more darker. So obviously they need a special attention when it comes to the brightness adjustment. So the structures in the far field, they need a special attention. They need more increase in the brightness. Why? Because they appear dull. So time gain compensation allows to change the brightness at any specific depth. We can either increase it or decrease it. So that's the TGC. Sween, can you please now repeat what we have discussed so far?
Okay, attenuation is the reduction in beam intensity. Basically, this is absorption from sound into heat, It is measured in decibels. So a few important influence, there is the frequency, medium, and the path length. Okay, and we can see clinical signs as shadowing and enhancement.
Okay, what are the name of the mechanisms of the attenuation?
There's absorption, there's reflection, and there's scattering.
Yes. And the main mechanism is the
Is from
absorption. Absorption plays a
yes.
main role. Okay. Now, what about the unit of the attenuation?
Decibels.
Its relationship with the frequency?
Is directly
Main mechanism?
absorption.
Attenuation coefficient value in the soft tissues?
Is 0.5 decibels.
Per centimeter per megahertz.
Like 1 megahertz.
Okay. Shadow indicates there is a high attenuation object. Enhancement indicates there is a low attenuation object. Okay, so Teswin, what's the dominant cause of attenuation in the soft tissues?
Absorption.
Okay, good. What is the attenuation coefficient in the soft tissues at 3 megahertz
1.5 decibel
per centimeter? Okay, which
per
has
centimeter.
higher attenuation, bone or fluid?
Bone.
Okay, good, bone. A signal drops from 100 milliwatt to 1 milliwatt. What's the decibel change?
Wait, so 100 milliwatt is 2. Okay, so 1 over 100.
10 log ratio. Ratio is final divided by initial. So final is here 1. 1 divided by 100. So what is the log of the 100 value?
100 is 2.
Yes, log 100 is 2. And log 1 by 100?
It's negative 2. But then
It's minus
attenuation
2.
doesn't have negative.
But now we are calculating its value. So we will put the value of log 1 by 100 as minus 2 to find our answer. Minus 2 multiply 10. Answer is minus 20 decibel, but we write it as plus 20 decibel here. Because we know that attenuation itself means that there is a loss. So that's why we write it in a positive number. Okay, why use a 3 megahertz probe for liver and 10 megahertz for thyroid?
Okay, higher frequency is less penetration. So it is good to use for superficial structures like thyroid. Low frequency, higher penetration, so it's good to use for deeper structures like liver.
Okay, good. So here we can see the explanation of all the questions which you already know, all the answers. So attenuation is the weakening of the sound. It's always in positive decibels. Absorption means conversion of sound energy into heat energy. It is the main cause of the attenuation in the soft tissues. Reflection means like sound wave bounce back toward the transducer. So we receive echo. So it plays a role in image formation. Scattering mean diffuse reflection. It spreads in all direction, so it provides the texture of the organs on the image. There are different kinds of medium. Attenuation depends on the medium, frequency, and the distance. Higher the frequency, higher the attenuation. Higher the distance, higher the attenuation. If there is bone, there is more attenuation. If there is fluid, there is less attenuation. Okay, so this means main cause of attenuation in soft tissues.
Absorption.
Okay, unit of attenuation.
Decibels.
What happens to penetration as frequency increases?
Frequency increases, higher attenuation, less penetration.
What tissue causes acoustic shadowing?
Shadowing. Bone. bone and air.
Okay, good. Formula for attenuation coefficient in soft tissues.
Rate of attenuation per unit path length is attenuation coefficient times with path length times with frequency.
So first question answer is absorption, conversion of sound energy into heat. Unit of attenuation is decibel. As the frequency increase, penetration decrease, and acoustic shadowing happens with the bone and also with the air. Formula for attenuation coefficient. So attenuation coefficient is, we know in soft tissues it's 0.5 decibel per centimeter multiplied by frequency. When we increase the frequency, attenuation coefficient increase. Like if there is a 3 megahertz probe, we multiply 3 with the 0.5 decibel. So the other formula we discussed, that was for the attenuation. So for the attenuation, the formula was alpha attenuation coefficient multiply distance or the path length multiply the frequency. For attenuation coefficients, it's 0.5 decibel per centimeter multiply frequency. Okay, now we will discuss the MCQs. So what is the attenuation? If your SPI exam is near, so I am there to help you. I have prepared 60 detailed SPI lectures covering whole ARDMS SPI content outline in a simple and easiest way possible. And I also have added MCQs in each of the topic. So you will get very easy explanation of all the topics along with the MCQs practice while discussing the topic, and along by the side you will do the MCQs practice. And I will also share all of the slides of every session for the easy review. And then I have MCQs test topic by topic. Like you listen one lecture and then you solve the MCQs of that topic. So you will evaluate your knowledge by this. And I have total 2000 plus MCQs to practice. I also have mock test so you can review your knowledge. And the great thing is there is a one-to-one revision session before the exam so that I can assess your knowledge and I can give you feedback what to improve. And there is exclusive bonus. I will provide you free guidance on ARDMS whole registration process. If you join our sessions, I will guide you about everything. Documentation, ARDMS supply guidance, exam booking procedure, SPI registration, A to Z, everything. So now you can enroll in our whole session, or if you have already prepared, you just need MCQs practice, or you just want mock tests, or you just need one-to-one revision session before the exam, so you can contact me on my email for all the details.